Welcome to the recorded lesson for Thursday 9/10 or Friday 9/11. So we were learning about bias in media, well, bias in scientific media and scientific studies. So our warm-up, there were 6 different options. I told you you were doing a report on greenhouse gases and climate change, and you had 6 different articles printed on different days and from different places to choose from. So I just asked you to choose one that would be considered reliable and why do you think it's reliable, and one that you consider not reliable and why. So most students pointed out that the more recent articles would be more reliable because it has more recent data. Things change over time. So the ExxonMobil 2020 article was a very popular one because it's from this year, whereas the Scientific American article from 1998, a lot of students said was not reliable since it was more than 20 years old. And then another thing that a lot of students picked up on was the source itself. So sources like Washington Post are a very well-known organization, whereas C27 Beanie's really rad blog no one's ever heard of before. So they wouldn't know why they should or would trust someone like that. Other people pointed out that the Royal Meteorological Society sounded like that would be a lot of a scientist, someone you could trust, whereas the Flat Earth Society doesn't believe that the Earth is round, and therefore their science will probably be very suspect. So there were very few incorrect answers that could be given for this round, but a lot of really good ones. Something that not many students noticed, but a few did, is ExxonMobil was the most recent article, and they do have a very large science department. So they would have a lot of really good research, but they sell fossil fuels that make greenhouse gases. So they might actually be a bit biased. They might actually try to play down the connections in their risks. Find my mouse, there it is. So after our warm up, we talked about what is bias and we went over some Google slides. Then you guys had a bias in research activity, and then you guys shared out your findings. And then I introduced the current event assignment. So bias in research. So whenever you're looking at research, you want something that is very objective. So objective means it is just the facts. It is not tainted by feelings or thoughts. To say that it is raining outside is a fact. To say that it's a gloomy day means that you're influencing your feelings. It's a sad, sleepy, gloomy day is a very biased, very non-objective way of telling the weather. Saying that it is cloudy outside is objective. So why is it important to have reliable scientific information? Well, you need to know, you need to be able to understand the issues that you see in the news. How do things affect you in your life? What are people trying to sell you on? You need to know how you can identify when someone is trying to sell you something, when someone is not being honest, and when someone is being honest. So, what is good science? Objectivity is the key to good science. That's how you know what you're looking at is good science. It's a good experiment and it got good data and you can believe its conclusions. So it needs to be objective. Otherwise, there's a strong bias and you can't really trust what they're saying. So bias is defined 2 different ways. There's 2 main ways you get bias in science. There's a prejudice or there's a consistent error in estimating a value. So if I'm ExxonMobil, I want to convince you to buy more gasoline. I'm going to try and show you the data, or I'll try to represent the data in such a way that will make you feel okay in buying more gasoline. If I'm Coca-Cola, I'm going to do studies about sugar and obesity and health in such a way that makes you feel better about buying a soda now and then. So, prejudiced presentations, they have a conclusion that they want to show you. Regular science takes a hypothesis, and you accept that your hypothesis will either be proved or disproved. You're open to either possibility. A prejudiced presentation already has its conclusion ready, and then it's just looking for data to back it up. Another bias can come from incorrect data, so an error in getting the values that you're looking at. So 2 main types of bias come from sampling and measurement. So a sample is the group that you're experimenting on, that you're measuring. If for right now, we are trying out COVID vaccines, they need to have a sample of the population to try their vaccine on that is representative of who is going to get it. We are going to be giving the COVID vaccine, hopefully, to just about everyone. So if they only test it on old white ladies over the age of 80, that's not representative of the world population. They need to make sure there's all ages, all genders, all ethnicities, so they can see if one group reacts differently than others. They want to make sure that it covers everyone. So some factors are sample size. If you only tested on 10 people and those 10 people seem to be just fine, it's not appropriate to then say you've got a good vaccine. You need to test it on thousands of people. The bigger the sample size, the more accurate your data is going to be. Next, how do you choose who's going to get it? You need to make sure that who you're choosing, who gets chosen, represents everyone. So again, if they just choose the little old ladies who are 80 years and older because they're the ones who had a free afternoon, they need to find another way to select participants because they need to have a larger sample. So some ways to minimize sampling bias includes a random sample. So you pull names. You select people from a list. You randomly choose who is going to be there. This is how a lot of juries are selected, actually. They usually randomly pull names off of voter registrations. And then limiting the question asked. You don't want to ask too many different questions. During class, we looked at teenagers who smoked and what percentage of teenagers smoked. So if they start asking them about other things like alcohol, drunk driving, other risky behaviors, that dilutes the data they're going to get. They want to stay on the point of their research and make sure that the questions that they ask get the data that they're looking for and not other data. Then you can have bias in measurements. If I am trying to figure out if my diet works, I'm going to have a huge issue if I weigh myself at the beginning and the end with a ruler. Make sure that you're taking the correct measurements with the correct tools. So measurements need to be taken correctly and consistently. Also, if I were to do a diet and I weighed myself in pounds and then in kilograms, that's a bit more of a realistic error, but that's another error because pounds and kilograms actually weigh different things, mass versus a force. No additions to the environment. You don't want your answers to be influenced by things outside of what you're studying. So if I hold my cat on diet day number 1 as I weigh myself in and don't hold my cat at the end of the diet, that's not going to give me a very good data about how much I actually lost because I may have lost or gained, but the change in mass from holding my cat is going to influence that in a big way. And then make sure that your experiment is designed to separate out the effect of multiple factors. So holding a cat is one way there, or not holding a cat. A fun fact about dieting and human weight is your own weight actually will fluctuate 1 to 2 pounds over the course of the day because you intake and excrete mass. Even just by breathing, we're taking in carbon and releasing carbon. So if you're doing something like weighing yourself and you know there's a lot of different factors at play other than just your diet, you might need to do something like weigh yourself at the same time. Usually, if you're tracking your weight, people usually recommend weighing yourself at the beginning of the day or at the end of the day. But always weigh yourself at that same time. So, minimizing bias, there's a few different ways that we can minimize bias in science. So, the first thing is replication or independent duplication. So, if your research is good, if your science is good, another scientist can go and replicate those results. If another person does your study and gets very different results, we all now know there was an issue with that initial study. So you want to try them over and over again to make sure your results are consistent. If you may have heard that in the 70s and 80s, there were a lot of studies done that showed that smiling could improve your mood. Even if you weren't happy, if you smile more, you'd be more happy. They did actually try to recreate those same experiments, and every time they don't get the same results. I'm still going to quote it because it's better than nothing, I guess. And the second way is a peer reviewed journal. Just like you guys look at each other's work in English class to help make sure it's on the level and it's the best work that you can make, scientists look at each other's work. They look at the data that was collected. They look at how the data was interpreted. If they notice, oh, hey, you left out some data, or hey, you said this went up when your data shows it went down, they can catch each other. They can help each other out. So, looking at studies, looking at articles about studies, there's a few different ways that you can tell if it's biased or if it's more biased or if it's more objective. First is the language. If it makes emotional appeals, if it makes value judgments like good versus bad, that's a pretty good indicator. It's usually not very good. You want to see scientifically proven black and white language that clearly lays out the data and the conclusions. So a good article might say, after talking to 100 people, 70% of the people all said that they dislike their long distance providers. Therefore, we need better long distance providers. That's a good article. That's a good way to show the data and make conclusions. If you're reading an article and it starts, it was a rainy Thursday. She came up to me with wet hair and eyes puffy from crying when I reached out to her and said, "Are you satisfied with your long distance provider?" "No," she wailed as she started to cry again. That's not a good science article. That's trying to tell you a story. It's trying to use flowery language to overcolor what's going on. So check the language. It should be dry. It shouldn't be too emotional. And there shouldn't be personal stories woven throughout. If there's personal stories, they're trying to show you their point of view. They're trying to show you their bias, really. Next, look at the data. If I said 70 of my 100 people didn't like their long distance, I shouldn't say, therefore, the long distance companies are doing a great job. They might just need to tweak themselves. That data doesn't really support that conclusion. All I know is that 70 don't like it. So make sure that the data and the conclusions actually match up. Make sure that the conclusion is appropriate for the data that is shown. And then lastly, look at where the data is coming from. Government research is typically considered to be pretty trustworthy. Is typically considered to be pretty trustworthy. Oh, oops, sorry. So is university researches. They tend to want to get the information out there. They want you to know what's going on and the effect that it's having, and they want you to make a decision after that. But whenever you see that it's corporate or research done by special interest groups, you should be very cautious because that usually means that someone has an opinion that they're trying to push off, they're trying to convince you of. For instance, Coca-Cola, like I mentioned before, does a lot of studies on sugar intake and health. Their studies and their research tend to tell people that soda isn't too bad for you, that sugar isn't too bad for you. Uh-oh, I'm offline. So make sure you see where the data is coming from, who is paying for it. Special interest groups are very sneaky. Special interest groups tend to have names like Citizens for such and such or People Against the blank and blank. They tend to have very deceptive names. Sometimes their name makes it sound like it is for one thing, but it's actually deeply opposed to something. So always be really careful. If you notice it's a special interest group, just be very careful. So then our classes, we went into breakout rooms and looked at some scientific studies. So for an example, where's my favorite one? Haha, here's a good one. I like this one. So Dr. Jackson is making observations at Davisville High School to investigate the rate of smoking among American teenagers. Dr. Jackson decides she will observe the students having their lunch in the parking lot where smoking is permitted. Dr. Jackson observes 25 out of 30 students smoking in the parking lot. Based on her observations, she records that 83.3% of American teenagers smoke. So her bias is a sampling bias. Actually, there's quite a few different biases here. I would say largely her bias is sampling. She didn't look at very many students. She only saw 30 students. And look where she got those students from. She got those students from the parking lot where kids go to smoke. If you're a student and you don't smoke and you don't want to be around cigarette smoke, you're not going to have your lunch out in the parking lot with the other smokers. So she cherry picked a population of the students that was much more likely to be smoking than the overall population. So she had a very strong bias that's going to lead towards a very high percentage of students smoking. So that is the kind of bias you guys were looking for in these different scenarios. Now let me go back to the flip chart. So then we talked about the CRAP test because you need that for your current events in chemistry assignment. Is that over here? There we go. So for your current events in chemistry, and this is due by your second class next week, although it is not due for a full 7 days, I highly recommend you do it this weekend if at all possible. I think if you don't, you might then have 3 different homework assignments to complete between your first and second class that week. So you need to find an article made in the last 6 months about chemistry, or really just science and the environment. We'd prefer it if it was chemistry based. You're going to make sure it is reliable using the CARP test, and then you're going to tell us about it. You're going to summarize it and reflect this. It is a 3-page assignment. So the CRAAP test is a way of deciding if something is credible or not. It's not a yes or no list. It's not a checklist. It is a guiding list. It's things to keep in mind when you're deciding whether or not it's a good article to use. So the C stands for current, or currency, it says here. When was it published? Is this a recent article or is this outdated? Has it been updated and revised? So how recent is this? For your article, it has to be in the last 6 months, so it is current. R is relevancy. Does this article actually cover what you need? Does it actually answer or address your research question? Is it an appropriate level? If you were doing something for this assignment, it might not be super appropriate to talk about the latest breakthroughs in quantum mechanics. That's not quite the level that we're at. Our current events project kind of smishes the 2 A's together, and that's authority. Who wrote this? Why do you trust them? A lot of students pointed out in the warm-up that they have a lot of faith and trust in the Washington Post and ExxonMobil because those are recognizable names. A lot of people did not trust C27 Beanie or the Flat Earth Society because they either knew they were incorrect or they could not verify that they were correct. If it is an author that is on staff, you can usually trust that. If it's an opinion piece and it's just someone giving their opinion, that's less trustworthy. Accuracy. Where do they get their data? Where do they get their information? Do they cite where they get their information? If they just start rattling off a lot of facts and they don't tell you where those facts are coming from, then that's not a very good source of information. And do they make judgments? Do they make value calls? To say that 70% of people are not happy with their long distance service provider is different from saying that 70% of all companies are horrible and you should hate them and make them feel bad. Make sure there's not emotional language attached. And then lastly, but very important, is the purpose. Why did they write this article? What are they trying to do with this? Are they trying to persuade you towards something? warn you away from something? Are they trying to just tell you something that occurred? What is the purpose? Why did they write it? Who are they trying to tell this to? I pulled two different articles about fracking. It's a bit of a controversial drilling technique. One from the Center for American Progress. It was published in 2011, so it's not super current, but 2011 isn't super out of date either. It's not a yes or no question if something is current. It's kind of current, it's kind of less current and not usable. I would say this is on the current enough side. Relevance, if I'm looking for about articles about fracking, this is pretty good. Making fracking safe in East and West. If I scroll down this article, I clipped some of it. It actually tells me a lot of the background information about what fracking is, the different terms, what is it used, how do they get it. So this is a very relevant article. Authority, well, if I look at who it is by, first off, they do give me the names of the reporters, and I can see Melanie Hart is actually hyperlinked because she's done several assignments for this publication. She's one of their reporters, so that's very trustworthy. I don't know who Dana Weiss is, but I can look him up if I need to. And the accuracy, well, they quote data and they have graphs, they have links to their sources embedded in the article itself. All of their data is very accurate and reliable. But then the purpose, well, I looked a bit more at the Center for American Progress. They're a very pro-industry website. They want to support American industries like mining and gas. So their articles tend to have a bias towards the industry, against regulation. They want to open things up and have more production take place. So this definitely seems to have a bit of a bias. It's very pro fracking. We can do this and we can do this safely, is the message sent by this one. So nothing was quite a yes or no, but going through these checks, I'm very aware of where the bias is or isn't. Another article I found was from the Pittsburgh Gazette, which was from this week. Sorry, not this week, from the past month. So it's very relevant, it's very current. It's warning people about whether that they maybe shouldn't sell off their land in Western Pennsylvania to fracking companies. Written by Alfred B. Bortz, who is not one of the reporters on the staff. He does not write for the Pittsburgh Gazette. He doesn't have many facts listed here. He talks about what's in there, but he doesn't tell you where he's gotten his information. He doesn't have any data to show you. He quotes some EPA regulations and laws, but other than that, there's not much data to say that it's accurate or inaccurate. I can't really determine. And the purpose is very clear. Be cautious of fracking claims. He's clearly trying to warn people away from it. So this might have some very good information, but you really need to think about all these different factors when you look at an article, regardless of what it is on. Okay, well, I hope this was a helpful recorded lesson. I hope everyone has a wonderful weekend, and I'll see you guys next week.